special cases. We did type 1 where we had a unique solution, which we also like to think of as an independent system or a consistent system. The idea was that if you graph those two equations, they will intersect at one point, and that point is the solution, which we were also able to find whether using the substitution method or the elimination method. So in this case, let us explore and look at these two equations and see what is special about them, okay? So to see what is special about them, let us start by actually solving these equations. Now, if I have to solve this equation, again, we have few different ways of doing it. Let us use one of the methods. So what I'm going to do here is, I see there's a -2 in front of this x here. So the coefficient of this x is -2. So what I'm going to do is I'm going to try to get a +2 right here in my equation 1. And then if I get that, then I can get rid of the x's, and let's see where we get from there. So in order to get that, we have to multiply equation 1 by +2. So I'm going to multiply equation 1 by +2. So it's going to look like this: 2 times x minus 3y. Of course, we have to multiply the right hand side. 2 times 1 is 2. And when we simplify this, so equation 1 finally transforms into 2x minus 6y equals to 2. That's my equation 1 transformed. So I'm not going to label this, but this is my equation 1, right? And then let me bring down the equation 2, because my goal was to get the coefficient of this one as 2, and then kind of add those two equations and see if we can get rid of one of the variables. So then I'm going to write this -2x. I'm just simply bringing down equation 2 plus 6y. I'm aligning the x's and y's together, and obviously the constants have to be aligned as well. Guys, I have these two equations already aligned correctly. Now what do? I just try to add them, because I see that there's a +2 and a -2 here. So if I try to add them, so now let us see what happens. And that is something special here. So this crosses out, I got 0. Well, in this case, the y terms also cross out, but we didn't want y terms to cross, but well, when we try to get rid of the x's, we are also getting rid of the y's here. So let's see what happens. So this crosses out, but if we add these two, you get a 7. So eventually, if you combine the left-hand side, then you get 0 equals to 7. But wait a minute. Let us ask ourselves, is it actually possible? Is it mathematically possible for 0 to be equal to 7? And we all know the answer to that is no, that's not true. So this is not possible. And now that is the special. That is why this classifies into one of the special cases when you use your method. Well, here we use the elimination method. Guys, if you use the substitution, you would still end up with something where left-hand side would not equal to the right-hand side, which for us would be like, it does not make any sense. So when you get something like this, then we like to think of this system as we like to think of this as a system with no solution. And this is also thought of as an inconsistent system. So this is also thought of as an inconsistent. So the last one where we had a unique solution, that was a consistent system, and this is an inconsistent system. Okay. Now, what does that mean in terms of the graphs? Guys, you can go ahead, if you have a graphing paper, you can graph those two equations and you can see what is happening as far as the graphs are concerned. But let me quickly show you a rough graph for both these equations. I have my x-axis and I have my y-axis here, and if we try to graph these two lines, this is going to look something like this. Roughly, it's going to look like this. Guys, this is my one of the lines, and this is the line 2. Now, what do we see here? These two lines actually are parallel to each other, so they do not intersect. So since they do not intersect, we're not going to be able to find one solution. They're going on forever. They're not going to intersect. And that is the reason why we have no solution, which we were also able to justify from actually using the algebraic method and then seeing something like this where left-hand side is not equal to the right-hand side. Okay, so it's an inconsistent system. Visually speaking, these two lines are parallel lines. So guys, these things all kind of are related to each other. If you have watched my previous videos on parallel lines, you can see now that these things do not just end up with parallel lines and perpendicular lines in terms of writing an equation of a line. They carry over to other chapters and other concepts as well. So they're all kind of interconnected. So here we can see that they have the, of course we already know that the parallel lines have the same slopes and all. So now here we can see that they do not intersect, we know that, and then there's no solution here, and that is special about this, and this is type 2. Okay, so type 1 where we have a unique solution, one solution where the lines intersect. Type 2 where the lines are parallel, we do not have any solutions because they do not intersect each other. So wait till my third video where we're going to talk about the last special case. Meanwhile, if you are watching these videos, you can think about what is the third thing that can happen. I mean, think about two lines. There's two lines. There's two equations. Well, they can intersect, they can be parallel, or what? Okay, but wait till my third video to find out what is the third case.